Welcome back. Before 1900, cases of lung cancer were very rare. But there was a noticeable rise in cases around the turn of the century. The question researchers faced was, why? In this video, I'm going to look at how researchers determined what was causing the rise in lung cancer cases. In 1900, there were only 140 cases of lung cancer reported in the known medical literature. Classifying, counting, and tracking lung cancer cases showed a substantial rise in cases from 1900 into the 1930s. One way to think of this identification in the rise of lung cancer cases is that researchers became aware of a potential changing or troubling situation. They focused attention on that situation, in our case, lung cancer rates, to determine if and the extent to which the change is occurring. Knowing that something is happening is only the first step in understanding the situation. As researchers, and as a society, we also want to determine why a situation is occurring. If we know why a situation is occurring, we may be able to intervene to bring about the outcomes we want. For example, if we could determine why lung cancer rates were rising, we may be able to intervene to reduce the number of cases, which would be a beneficial outcome. There are different types of theories. Most theories are in the form that they explain why a situation arises. Some theories explain why a circumstance occurs by associating two factors or two events. For example, the theory that smoking cigarettes, event 1, is associated with lung cancer, event 2, explains why lung cancer cases were rising. The value of this type of theory is based on it accurately explaining why a situation or state of affairs arises. In that way, it is always oriented towards describing or matching what is occurring in the world. There are usually multiple explanations we could plausibly adopt to explain a situation. Faced with a novel rise in lung cancer cases, researchers speculated on its cause. Potential theories included that lung cancer was caused by cigarette smoking, tobacco dust, asphalt dust, air pollution, the latent effects from exposure to poison gas in the First World War, or even latent effects from the 1918 influenza pandemic. We want to direct our actions based on our theories to bring about outcomes we want. It's therefore important to get our theories right. If we looked at the theories first proposed for explaining the rise in lung cancer cases, depending on which one we adopt, we may direct our actions towards restricting smoking, reducing asphalt pavement, or waiting for the latent effects of the First World War to pass. As we've seen with the amount of societal effort required to reduce smoking rates, we need to be as sure as possible that we get our theories right. Just imagine that rather than putting these efforts into fighting smoking, we spent the last 60 years trying to reduce societal exposure to asphalt pavement, and what the likely impacts on lung cancer rates may have been. So how should researchers go about to determine the right theory to adopt? A traditional theory should match what's happening in the world. One way to get some evidence regarding which theory is best is to closely examine and measure the world. But the world is usually too complicated to figure out why certain situations are occurring just through careful observation. Often multiple theories are proposed because they all plausibly match what we can normally observe. Just think about the connection between smoking and lung cancer. It's not that you can watch someone smoke and that it directly leads to lung cancer. It can be years of exposure before there are any signs of cancer. The person may even have stopped smoking by then. To determine which theory is correct, researchers often design tests or experiments to help select the right theory from among plausible explanations. To determine that cigarette smoking was associated with the rise in lung cancer cases, researchers compared multiple times in different places the characteristics of people who had lung cancer with those who did not. These are case control studies. They followed cancer-free populations of smokers and non-smokers to see if one group were more likely to develop lung cancer in the future. These are cohort studies. They conducted multiple experiments exposing animals to tobacco components to see if the animals or the animal cell samples were more likely to develop cancer compared to those that were not exposed. They analyzed cigarettes and cigarette smoke to determine whether there were potentially cancer-causing chemicals present, which could explain why the cancers were occurring. After about 30 years of study, the confluence of these diverse forms of evidence from epidemiology, animal experiments, clinical observation, and chemical analysis, combined with diminishing evidence for alternative explanations, prompt health and medical authorities throughout the world to publicly acknowledge a cigarette cancer link. By designing experiments that focused on the factors causing lung cancer, researchers generated more evidence relevant to our task of selecting the best theory. The research evidence collected involved various types of studies and results. All this evidence is considered in comparison to the evidence for other viable explanations. The evidence was viewed and critically assessed by researchers around the world. Based on all these efforts, a consensus was reached by the scientific community. Smoking cigarettes was associated with an increased rate of lung cancer. I'm going to call this work to determine what actually is the case and what theory correctly characterizes why something is occurring in the world as truth-focused. Truth-focused research is focused on capturing the world correctly. But what happens next? Who's supposed to bring about the change? In the next video, I'll discuss the distinct roles of researchers and policymakers and members of the public within a traditional model of research. Thanks for watching.